Oh, that's very interesting. Amazing poll you're running. A lot of Spark streaming users.
Yeah, no, it's pretty cool. So I should have probably added more because I'm seeing a lot of people answering others as well. So
yeah, it will be interesting to know what are those other streaming platforms. So feel free to to use the chat for that. I'll be excited to know.
Cool. All right, so I think we're live on YouTube as well. So without further ado, I'll get started. So welcome. It's an exciting day. Our team and I were talking about, we not only have the workshop, but we did an exciting launch too, so which I'm sure we'll talk about in a little bit. Just a couple of housekeeping things. We do this for all of our events, whether it's in person or virtual. We do have a code of conduct. You can look at the details there in our GitHub repo. Let me know if you have any questions. I think a lot of you probably attended previous workshop, but if you have any questions, you don't have to wait until the reserved Q&A time we have on the agenda. Anytime you have questions, just feel free to ask them live, and then so we'll address questions as they come. It also helps us, rather than posting on the chat, having in the Q&A really helps us, because we look at the Q&A report at the end. We use that to improve our documentation, for example, so it's very helpful. During our demos that Igor will be doing, we'll be using kubecloud. But all these features are, also available on our open source version of our software. I mean, if there's something that's for kubecloud only, I doubt that's going to happen today, but we'll specifically call that out. As I mentioned earlier, the recording and the slides will be posted on our event page, and we'll have links to the YouTube channel. So you don't have to take screenshots or take furious notes. So we'll get that available after the event. Speaking of after the event, we'll have a short survey that really helps us sort of improve our future events and what other topics you might be interested in. So yeah, I mean, that's it for the logistical stuff. What I'll do is I'll stop sharing and turn things over to you, Artyom, if that works.
Sure, thank you. Right. Okay, so let me go into the slideshow, and you all can see my screen, right? All good. Yeah, thank you everyone for joining today. Excited to chat more about the streaming support in Cube and our roadmap and integrations and all of the new things that come into Cube. My name is Artyom. I'm a co-founder at Cube. Together with Pavel, I'm one of the original creators of Cube. And today we're going to talk about our support for the streaming data. We'll talk a little bit about what is Headless BI, because we call it a Headless BI with streaming data. So it would make sense to sort of reiterate when we talk about Headless BI, what we mean by that. We also will talk about ksqlDB integration, which is the major streaming data source that Cube now supports. And then we'll talk about Lambda pre-aggregations and what are they, what is their Lambda architecture, and how you can leverage them. Even if you're not using streaming data sources, Lambda pre-aggregation still can be useful. So I will start with the Headless BI. You probably noticed that maybe like 6-8 months ago, we started to call Cube a Headless BI. And I think the term is good, and it describes what Cube really is, especially that the headless part, because we don't have visualization. And just as a reminder, where Cube sits in the modern data stack is we usually sit between data sources, mostly cloud data warehouses, but now streaming data sources as well, and multiple data consumers. And traditionally, there are like a lot of issues that you may see and face when building this architecture is like where I define my data model or metrics. How do you manage access to data? How do I build APIs? So all of the things that Cube is basically solves. That's why we call Cube a headless BI, because Cube does the BI things like data modeling, access control, caching, API, but it doesn't have visualizations. So Cube, instead of providing Cube with visualizations, Cube gives you a set of APIs, REST API, GraphQL API, and we recently released what we call a SQL API. So now you can use these APIs to connect to Cube from different tools. Many of you using maybe React and other custom built tools, but we recently released SQL API, and now you can leverage business intelligence tools on top of Cube, such as Tableau, Superset, and Metabase. So that's sort of a recap. You can think about the Headless BI is a platform that sits on top of data warehouses. It does the data modeling piece. It does the caching piece, access control, and then a set of APIs. And the benefit is that you can put all of this data into your applications. I will monitor questions as I go, because some of them I can just quickly answer. And someone just asked me, would it be fair to say you compete with Streamlit? I would say Streamlit, when we think about the headless architecture, Streamlit going to be here on the right. And I think we even have a Streamlit logger here. So the way that Cube works is, for Cube, Streamlit would be more like a data consumer or data application that should sit on top of Cube. Your team may use some embedded analytics, customer-facing applications. Some of the team may use Metabase, and then maybe some of the part of the team would use Streamlit. So in that case, Cube will provide data to all of these tools, including Streamlit. But again, Streamlit is a visualization data consumer tool from the Cube's perspective. All right, let me move next. And as Ray just mentioned, we had a big release today. We just released what we call views. And we will not talk a lot about views today. Obviously, we're going to talk about streaming data sources, but since we just released it today, I wanted to highlight that release. The views is additional concept to the Cube data modeling. So for those who are already familiar with Cube data modeling, the main object you're working with is Cube, right? Obviously, that's how you model your data. But the problem with that is it sort of creates a data graph that's being exposed as a huge data graph to all the data applications. And one thing that we noticed, and thank you for all community that provided us feedback, is the question is like how we create a sort of a public interface, or like how we create a facade to this data model and manage what can be exposed to data applications or what cannot be. How do we control a joint pass? How do we do aliasing? How we manage metrics? All of this. So all of these questions, they led, for us to create this additional layer, sort of a facade on top of your data modeling layer. So now you can leverage views to manage what part of the data model should be exposed to different data consumers, like how you define metrics in these views, how you manage the join paths, all of this sort of features and data modeling scenarios you can leverage views for that. We have a blog post that goes into some details, and also there is a documentation. And finally, we will run a workshop on views in about 3 weeks. So if you would like to learn more about views and to start using them, just sign up for that workshop. We will go into details on how you can use them, and we will go into different scenarios such as metrics management, visibility governance, and controlling the join paths, and how you can solve this scenarios with views. So now finally, let's move to the streaming data, the topic that we're going to cover today. So the main change when we say about Cube as a headless BI can now run on top of streaming data is that we just released an integration with ksqlDB. We had a materialized integration for a while, and now we're adding a ksqlDB. So here on the slide, you can see that you can still run, obviously, Cube on the batch data, cloud data warehouses. And that's how most of the users and most of you using Cube right now. But what we're adding to the mix is a way to run Cube on top of the streaming engines such as ksql and Materialize. When I say streaming engines, there's not a lot of them. So there is a ksql, there is a Materialize, Apache Spark Streaming, Apache Spark Streaming, and a few others. I know we ran a poll, so and some of you answered others. So what would be helpful if you can post in the comments right now or in the chat if you use something that you didn't see in a poll, that would be very helpful, because we obviously started with ksql as a first streaming engine, but we wanted to continue to build more and more support with different streaming engines. So to understand what our community is using today and what our community is planning to use will help us basically to guide our roadmap and to prioritize. So let's talk about support for the ksqlDB specifically. So what is ksqlDB? So ksqlDB is the streaming database developed by Confluent. It's being supported by Confluent. It's open source. It also being a part of the Confluent Cloud. So if you're using Confluent Cloud, it's just an easy way to spin up a ksqlDB cluster. ksqlDB works with Apache Kafka, but it also works with Red Panda. So if you're using Red Panda, you can still use ksqlDB. So what it does, it allows you to run a SQL processing on top of your Kafka topics. So when you stream your data with Kafka, you can leverage ksqlDB to create so-called streams or tables. That's a way to materialize and sort of like a process results and package them as a table, as a SQL table, and then you can build on top of this. So you can run one transformation into one stream, then transform that existing stream into the second stream. So you can pipe them to sort of create some sort of a transformation with a SQL. And then finally, you can query them. There is two ways to query ksqlDB. One is called push and one is called pull. The push query is that when you subscribe to changes from a ksqlDB, it's so-called emit changes operation. So you're basically telling ksqlDB, I wanted to calculate, give me the sum of sales, right, or something. So you run select sum sales, and then you do emit changes. And then every time the sum changes, the ksql will give you an update. And there is a pull query where you just, like as a traditional database, you just ask a question and you get an answer back. So that distinction is important because we will talk about later how Cube works with ksql specifically in regards to push and pull queries. And Igor, feel free to, tell me when you wanted to jump into, and do the demo. But I will first go through this general overview of how to work with ksql. So first of all, you connect ksql to your event streaming platform, which is usually Kafka. Again, you can use with Red Panda, but Kafka is obviously the most popular one. You can create a stream with a SQL-like syntax. And then you also can not only create like a plain table, plain stream out of topic, but you can also do some transformation with a select statement. So you also can create tables, and streams and tables are different concepts in ksql. We'll not go into a lot of details and the difference between them, but just like a simple rule of thumb, usually if you want to do some sort of a transformation or group by, aggregation or group by, you probably need to use table. And then once you have a table or stream, you can access them with either pull or push query. So how it all works with Cube. So you first have a topic that you stream through the ksql. You create either stream or table, and then you connect Cube on top of that. So you connect ksql to Cube as a regular database. So you just put credentials, host, username, and then in Cube, you need to create a data schema. Obviously, that's going to address the table or stream. And then you need to define pre-aggregations. So the main difference between other data warehouses and ksqlDB specifically is that Kube cannot query ksqlDB directly. It always needs to pre-aggregate that. So Kube uses the push queries together with pre-aggregations when it queries ksqlDB. When you create a data schema in Kube that works on top of the ksql, you need to create a pre-aggregation, and we call this pre-aggregation a streaming pre-aggregation, because unlike the traditional pre-aggregation, streaming pre-aggregation, it's not pulling the data source for the updates, but it subscribes to updates from the data source. In case of the ksqlDB, Kube uses emit changes or push query, and it subscribes to the changes from the ksqlDB. So when you run your ksqlDB and you run a Kube always listens to the updates from a ksqlDB and uses its updates to refresh its own cache, its own pre-aggregation. And then when query comes in, Kube will serve that query not directly from a ksqlDB, but from its own pre-aggregation in a Kube store. But that pre-aggregation is always being up to date because it's connected to the ksql through the push query. So again, we call this streaming pre-aggregations, and we're going to use the term in a documentation for all the future streaming data sources as well. So just the main difference is that with the streaming pre-aggregations, updates are constantly being pushed from the data source into Kube. With traditional pre-aggregations, updates are being pulled, right? Those of you who already use Kube, you know that you usually write a refresh rules like every hour or maybe every day, or based on some SQL triggering, and then you just Kube goes and get new updates from the data source. That's a regular pre-aggregation. In case of the streaming pre-aggregation, you always have this channel open, and a Kube always gets the new data from the streaming data source. So that's sort of a recap. Again, streaming pre-aggregation use push queries in ksqlDB. You don't need to define refresh key because they're always up to date, they're always streaming. And right now, the only data source that we support for streaming pre-aggregations is ksqlDB. We plan to support Materialize soon as well for streaming pre-aggregation, and we'll talk about our roadmap a little bit later. So now I think I can ask Igor to take it from here to chat about the demo. And I saw a question in the chat about the demo, and that's exactly what we're going to show you right now. We have it online, we have it on GitHub, and Igor is going to show you this demo right now.
Yeah, amazing. Thanks for this introduction to the Headless BI with streaming data, Artyom, and a lot of interesting things are going on right now with this new kind of features with streaming pre-acts and stuff. Yeah, so now is the time for the demo, and yeah, this demo is available online. So here's the link, and I'll be showing you in a second. But first, let's quickly talk about what you're going to see. So this is a web application which shows some web analytics, right? So you come to this page, an event is fired, it's sent to Twilio segment, and then from there, these events, they are produced into Kafka, and then from those Kafka topics, the data is materialized with ksql, and then it's pushed into Kube, and then Kube exposes an API, a REST API in the case of this example, and then with WebSockets through that API, data is channeled back to the app. So this is the architecture, right? And well, it might seem quite complex, but I would say it's quite telling as well, right? So probably in your production application, you'll have the same tools, but with presumably more complex setup. Okay, so let's see the demo. So yeah, this is a real-time dashboard, and here you can see that, well, something's happening, right? So so first of all, you can see that every 5 seconds there is an event which is an event is being sent to the backend. If we go to their network tab here, we'll see that the queries they're flowing, and then you can see that that's only happening for me, but also there are some other users online. So what you can do, we can probably click this button a few times to produce even more events, and with a short delay, we'll see these events kind of piling up. Okay, this was a spike. I can continue doing so, and yeah, you'll see the spikes appearing on the chart. And this is an interesting chart because it showed their real-time state of things with a really short delay. You can see the delay is probably 2 or 3 seconds. That this is what happened. This is what's required for the data to flow through segment to Kafka to ksql to Cube, and then back here to the front end. And every time an event is produced, every time the button is clicked, these counters, they are updated. At the same time, you can see this real-time stream of events. They have different hashes, so you can see they are really updating here. But also you can see that we are also representing the data in a historical way, right? So this is activity during the last day, and yeah, probably here's the moment when our workshop started and everyone started to play with this one. However, now that we know how this demo works, let's drill down into their source code, into their infrastructure, and see how that all works. So now you know that the events are produced to sent to Twilio segment, and from there they are sent into Kafka. So let's go to the Confluent Cloud. So here's where we have our Kafka cluster as well as our ksqlDB cluster, and you can see that there are some metrics for the throughput and and the consumption of this cluster. We can go to their topics view, and instantly you'll see a number of topics here, and yeah, for some of them there are some activity, and then if we go to the ksqlDB section and drill down to the cluster, we can see that there are some persistent queries running. This is exactly their SQL queries ending with the emit changes part that you run once, and then they continuously materialize the data from Kafka topics. So yeah, so you can see that there is this kind of users last timestamp, persistent table, and then a number of others, and the full list of them is shown here in the sidebar. Okay, so this is the Kafka and ksql side of things. Let's go to kubecloud. So here's our deployment that powers this demo application. So it's a kube deployment running in kubecloud, which is very convenient. So because we will have we'll have a lot of convenient tools when browsing the code. And yeah, indeed, let's browse the code. But before we do so, let's go to settings and configuration. So we are really aware that we are talking to ksqlDBs, right? So the database type here is ksql, and here's the URL of our ksql DB instance, right? So we are really connecting to Confluent Cloud. Okay, now we established that. Let's switch to the schema. So you can see that we have a couple of cubes here. The first called events, and the other is called online users. And as you can see, there are tables from which we select the data here. They match what we saw in the here in the case in the sidebar. So here's the events table, right? And indeed, we're doing select star from events. And as you can see, there are a couple of really trivial measures and dimensions, like this count for the total count of events, and a distant count of user IDs that translates into the user count, and yeah, and also have a time dimension here. And the real thing to take a look at here is this pre-aggregation section, right? So you can see a couple of roll-up pre-aggregations defined, and well, I'm claiming they are roll-up pre-aggregations because this is the default type for pre-aggs that we have, right? So yeah, you can see that this pre-aggregations would accelerate any query that that has kind of a subset of these measures and dimensions. So if you want to see count, by time, or if you want to see the number of events of any type, or for any user with any ID, well, this pre-aggs would accelerate those queries. And indeed, we could go to the queries tab and see the queries which are incoming to our Cube deployment. So yeah, it takes some time to load them because, well, indeed, there are a lot of queries, firing every second, right? But yeah, now we see them. So yeah, you can see that these queries, these queries are running, yeah, as I said, every second, lots of them, and they are all uncached. It means that they're being served live from the pre-aggregations, which are continuously updated from ksqlDB. And we can go here and see the essence of those queries. So yeah, his online users count for the last 30 seconds. Probably that's something that that powers this metric, right? And you can see that by this bolt that it's being accelerated by this pre-aggregation. And if we navigate back and we pick some other query like this one, you also see that, well, it references users count with a granularity of hour. Probably this is something that should be powering this chart, right? And just like the other query, it's accelerated with this other pre-aggregation. And yeah, that's why after we refresh this demo, the data instantly appears on charts, and that's why all the data is being continuously updated. So yeah, this is the under the hood part of this demo, right? So you have this web app, you have your topics and materialized tables in this Confluent Cloud, where our Kafka cluster and ksqlDB are running, and then you have this Cube deployment, which is running in Cube Cloud. Yeah, and then through its REST API, the data is channeled back to this web app. If you wonder where you can get the source code, well, it's on their GitHub, right? So you can go to examples, search for ksql, and here's your source code, right? The Cube data model is under schema, and the front end app is under dashboard app, and we'll surely share the link in the chat. Okay, that's all for this demo.
That's great, Igor. And I think we have a few questions being asked during your demo. So maybe we
can ask
them.
Yeah,
I think
there are a couple of questions. Yeah, I think there are a couple of questions that are directly related to the demo itself. I think the first one's from Tom. You see the count measure is type number. Is there a way to support rollup of count distinct, or is ksqlDB incompatible, with count distinct approx?
Yeah, I think I can take that one. So unfortunately, there is no easy way to do that. The reason is that ksqlDB doesn't support count distinct approx. It, as you know, count distinct approx uses the hyperlock algorithm under the hood to calculate this approximation. ksqlDB actually uses hyperlock internally as well for its count distinct function. But what happens when you run a count distinct function? ksqlDB will use hyperlock internally and will give you basically discrete numbers, like just this approximation numbers. And then you can use that with a cube, and you can use rollup on top of that. But you cannot use cube's count distinct approx type, because for that, cube needs to be able to access the underlying vector data type to be able to download that into Cube Store and then just kind of apply the algorithm on it. But ksqlDB, they do not expose that underlying data type. So there could be workarounds around using count distinct. I think in the demo that we showed on a GitHub, we actually have a case with a count distinct. As you can see, we show the online numbers of users, right? And then we use count distinct function to show that online numbers. But we use some upstream transformation in a ksqlDB to get to that number and then just leverage it downstream with a cube. So unfortunately, right now there's the only way to do that.
Yeah, there is also a question from Krishnamurthy, yeah, the question is that person is currently evaluating the Cube Cloud and the free tier, performing a proof of concept, and the ksqlDB is used, and it looks like a strong use case for streaming DB. So the question is, like, being a free tier user, is it possible to use their ksqlDB connector? Artyom, what would be our answer to that?
Yeah, it is possible. Please ping us in Intercom and just ask the team in Intercom to enable the ksqlDB for you.
Cool. And there's other question which is quite interesting. So the question is, what's the difference between the Cube's pre-aggregations and the aggregations that can be made on Elasticsearch? Elasticsearch seems to be more flexible, as it can work over the Kafka stream itself, removing some extra layers. How would you approach that, Artyom?
That's a really good question. I think that that question is about Elasticsearch, but really we can think about any other sort of like OLAP database that would support OLAP queries, right? It could be ClickHouse, it could be Pinot, it could be Druid. So the question is, should we just stream data into this sort of database serving layers and then read the data from them instead of running ksql on top of streams and just kind of consume it from a cube? So that's a valid alternative. I think we can share the talk that our CTO Pavel he did about that specifically. I think it was last year on a ClickHouse event. So what is the trade-offs between different architectures? So I wouldn't go into a lot of details here. I think overall that architecture where we would introduce the serving database such as Elasticsearch potentially can bring more overhead in terms of the maintenance, especially around supporting transformations. So with the ksqlDB, you still can do transformations with streams. ksqlDB unfortunately doesn't support DBT for transformations, right? But if you would look at materialize, they can support DBT. So now it means that you potentially can have all your transformation being managed through the single sort of a system. Like you use the same SQL-based transformations for the materialize, for the Snowflake, and then you can just join all them together through the Lambda architecture and then serve them through the cube. In case of using something like Elastic, you would need to probably do a different transformation logic. And then there are like some other differences. I wouldn't say the one architecture is just better than other. It's just like a set of significant differences between two of them that one needs to consider when deciding. But I think we can share the Pavel's talk about it. He really goes into details and the difference.
Yeah, I already posted the link to the talk to the chat. Yeah, okay. Yeah, and there's one more question, which is a really interesting one. So the question is, how does Cube differentiate itself from a data virtualization tools such as Denodo that offer modeling, aggregation, caching, and access APIs kind of under a single umbrella? How would you approach that, Artyom?
Yeah, good question. It's the first time someone asked me about the difference between Denodo or Denodo. I'm not sure how to pronounce that correctly, and a cube. But it's a valid question. I would try to answer about the data virtualization as a category, right, versus like Headless BI as a category. I think the data virtualization as a category, it's been here for a while, and it does a lot of things. When you say about data virtualization, you know, like people expect some enterprise software that does a lot of things, where like Headless BI, it's obviously the modern approach, and it fits more into the modern data stack. So I think if you look at the differences, the first is just a different generation approach. But I think the major difference is that data virtualization idea is that you don't need to ETL data. You just keep data in places where you have a data. You don't need to put it into warehouse, and you just run. You know, like you create the facade to your data through this data virtualization software. Where like a cube, any headless BI layer is really focused on this, you know, like on data warehouse centric architecture. So we encourage people put your data into data warehouse first, and then run Cube on top of this, run your Headless BI platform on top of this. And I think in terms of the use case, data virtualization is usually, when you think about data virtualization, you expect, you know, like accessing data within organizations, you know, like different functions and roles, where like Headless BI is really designed to power data apps, whether it's internal data apps, external, customer facing. It doesn't want it to be a face. It doesn't want it to present data to the final consumer. It wants to power the applications and power embedded analytics, power data apps. So I think that's just a set of differences between these two categories.
Cool. And it looks like with that, we are ready to proceed with the next part of our presentation. Artyom, will you?
Yeah. Yes, sure. Right. So the next part of today's workshop going to be about so-called Lambda pre-aggregations. And that's something that we released.
Sorry, Artyom, I think you may have skipped the slide on the streaming roadmap. Like,
oh, the streaming roadmap. Sorry, yeah. Right. Let me try to quickly touch on that. So I already mentioned that we're going to support Materialize, streaming pre-aggregations in Materialize. We already support some sort of a pool queries. I don't think Materialize use this term, but we support the queries that can sort of, you know, like get data out of Materialize. We cannot subscribe to updates from Materialize, and meaning that we don't have support for streaming pre-aggregations in Materialize yet. That's something that we want to do. And please ping us if someone, you know, on this community call or this webinar is using Materialize. We would love to chat with you. We'd love to learn more about, you know, like different needs and different use cases. That would be very helpful for our product team. In terms of the ksqlDB, you probably noticed that ksqlDB currently is in preview. So there are like a few things that we wanted to finalize with ksqlDB before we release it into general availability. Now, here is the list. It's just a very technical things that mostly should be designed to run it in a high reliable and high resilient environment. If you have, and I know some of you already mentioned that you have a good use case for ksql. So if you would like to help us, you know, like to build the ksql integration and you wanted to try it out, just please ping us in Slack or here in chat. We would love to partner with you to finalize ksql and to release it to into the general availability. We are aiming to release it by the end of the year. So if you wish to wait instead till the GA, that's totally fine too. So it should be available around the end of the year. with that, let me move to the Lambda pre-aggregations. I know we have only about 15 minutes, so I'll try to go quickly. But Lambda pre-aggregation is really important features that we released together with a ksql integration. So Lambda pre-aggregation gets its name from Lambda architecture. Maybe many of you familiar here on this concept, but I will just give a quick overview of that. So it's an architecture that helps you to process both batch and streaming data. It usually describes a system consisting of 3 layers. One would be a batch layer, basically your historical data usually. Second would be a speed or real-time layer, usually streaming layer like a Kafka. And then it's going to be a serving layer. Serving layer is something that unites the data, but also responds to the queries. So that's how you can, see that being visualized. And now that's why, it's getting its name, right? Lambda, as you can see on this image. So with Cube specifically, as you probably can guess by now, the Cube can act as a serving layer here specifically. So if we will look at the schema right now, we can see the batch layer could be your batch data in a data warehouse, like a BigQuery, Snowflake, or Redshift, and the streaming data in the streaming layer could be something in a ksql and materialize. And then what Cube can do as a serving layer, Cube can build a batch pre-aggregation for the batch data. Cube can build a streaming pre-aggregation for the streaming data, and then run a union during the query processing. And then just display this union data to BIs, embedded analytics, or data apps. So Cube can provide you with a Lambda architecture here and act as a serving layer. The way you would do this, you would just build 2 pre-aggregations, one batch pre-aggregation, one streaming pre-aggregation, and then you would build what we call a roll-up Lambda pre-aggregation, right? As you can see, this definition of this pre-aggregation is on top of this. So while that is very helpful, not all of you using the streaming data, and we know that, but Lambda architecture or Lambda approach can actually be used not only with the streaming data, but also with the source data as well, with the batch data, cloud data warehouses. In that case, you can think about Lambda approach a little bit differently. So the batch layer is going to be your pre-aggregation. So imagine you have a Snowflake with 10 years of historical data, and you don't want to go to Snowflake every time you want to query all the 10 years. You probably want to pre-aggregate all the 10 years down to the yesterday, right? Every 10 years and a yesterday. So you can do that, and you can create that pre-aggregation and put that pre-aggregation in a Cube. And that's going to be a batch layer. And then you can query your Snowflake in real time for the last day, for today, right? So that's going to be a serving or real-time layer. So what Cube can do, Cube can then union data from the pre-aggregation of the 10 years of data, and then the real-time piece coming from a Snowflake, and then union this data during query processing, and then send it to your data consumers like APIs or custom applications. So the way it's going to look like in a data model like this, so you need to build a batch layer, which is going to be your pre-aggregation. You using build range start or build range end, you decide, on a window. It could be rolling. So you can say, I want to pre-aggregate everything since 2020, January 1st, 2020. And then maybe you can do like everything till the yesterday. And that yesterday piece is going to be rolling, right? And then you can have a Lambda pre-aggregation. And Lambda pre-aggregation, its job is just to tell, I wanted to get this batch pre-aggregation and apply the new data to it as well. That's going to come with the source data. That's why we have a union with the source data true here. And I think I can give it to Igor right now to show a quick demo how it works. This feature is available right now, both in open source and a Cube Cloud. So you can try it today with your data. You don't have to have ksqlDB or something. Again, it works with any data source already, whether it's Snowflake, BigQuery, Redshift, or even Postgres.
Right, and here's how it works. Okay, we're for the next demo. I've come to the index page of the KubeDev website, and the reason for that is that we're gonna do another web analytics demo, right? So if you take a look at what happens when you come to our website, right? You might see some tracking requests. So I navigate to the product page, I navigate back, and when I do that, some events are being sent to the backend that we maintain, right? But this is just regular web analytics, right? And well, we've got quite a few of those events. So the data is flowing through a cloud function to BigQuery, and here I got a Kube deployment which is set up to work with that data. So if you go to the playground and select the count of those events, well, we'll see that, well, over the last few months, we've collected, quite a few of those events, right? So, just like with other example, you can see that we are working with BigQuery. There are some BigQuery credentials right here, and the database type is indeed BigQuery. Okay, let's take a look at the schema for this demo, right? So we have a single cube called events, and and as you can see, we are doing just select star from this events table, which is a giant one, and there are some really trivial measures and pre-aggregations defined. This is this count measure that I was querying, and obviously we might be interested in IP addresses or user agents or some other properties which were sent to the backend. However, this is not something that we are interested in right now. But let's take a look at the pre-aggregation setup. So here you can see just a regular roll-up pre-aggregation, which says that that we want to pre-aggregate the count measure and also the timestamp with a daily granularity. And since we've got a lot of events, we prefer those that pre-aggregation to be partitioned. So every month goes into a separate partition, and then it doesn't. Since this is a data which never gets updated in historical perspective, it makes sense to use incremental pre-aggregation. So we just rebuilding the last partition every time, and we'll be rebuilding it every hour. And since we're going to use the Lambda pre-aggregations here, it makes sense to set the range start or range end for this pre-aggregation. So it will include only the data from the January 1st, 2020 to, and that's interesting thing. This is something that Artyom mentioned when he was describing the Lambda pre-aggregations. So this is a rolling range end, right? So we are subtracting 2 days from the current timestamp, and it means that the last partition will always have the data which wouldn't include the last 2 days, and for that data will be going to our data warehouse every time. So this is our roll-up pre-aggregation, and as you can see, there is another one called Lambda. With the type rollup Lambda, right? So that's not much to set up here, right? It just refers to the first pre-aggregation, to the batch one, and it also has this flag union with source data true. So this is all you need to set up Kube in a way that it follows the Lambda architecture and allows you to read some read some data and build pre-aggregations kind of with this batch part of your data, and at the same time be able to query the data in real time, query the most fresh of your data. Okay, so let's now see how it works. So I go to the playground. Probably no one remembers what was the last number here. So let's try something else. I'll select the timestamp dimension, right, and just run this query. Yeah, let's see what's the very last data point we have here. Or probably I should select the line chart type. Yeah, okay, it works. Too many dots. Should I just say this here? I just wanna, yeah, okay, makes sense. So we can see that today on October 13th, 2022, the events count is yeah, so it's 948,798. Okay, so 798 in the very end. That's what we're interested in. And as you can see, this query took just slightly more than 1 second. It was accelerated with pre-aggregations. If we go to the queries tab, we'll be able to see how that works. So this is the query that which we ran. It was accelerated with pre-aggs, and if we drill down, we'll see the measure and dimension that I specified in the playground UI, and this is their SQL that was run against. It was run to make to execute this query. So something interesting is happening here. So these are not big query tables. These are individual partitions of their events batch pre-aggregation, and you can see at the very end that there's also a union with another table that represents the Lambda pre-aggregation. So what happens here under the hood when we're running this query is that Cube is reading data both from the rollup pre-aggregation and the rollup Lambda pre-aggregation, unioning the data together and then showing the result. So yeah, okay, let's run this query once again. So it's 798 in the very end. Okay, just refreshing this page. I'm sure that there are some events incoming because, well, our website is quite popular. Let's check the result right now. Okay, it's changed, right? So we have much more events right now. And now we have 430 in the very end. I can refresh this once again and check the result. Okay, it's different number again. And what if I do it just one more time? Yeah, it changes indeed. So this is a way for you to use the Lambda pre-aggregations with your cloud-based data warehouse, right? And kind of get the best of both worlds. You use just regular pre-aggregations, which frankly save you money because you don't need to read data from your warehouse every time you use your query, and at the same time make sure that every query that you're sending through Cube to a data warehouse, it gets the most up-to-date, the most fresh response. So yeah, here's a demo for Lambda pre-aggs.
Thank you, Igor.
Cool.
I think we have only 3 minutes, but we have 2 questions, and that I can try to answer. They actually sort of the same question about sort of consistency and how we make sure that like we're not getting duplicates. That's a very valid question, and I think it could be more to that conversation. And I will try to give just a high-level overview answer right now. But what we can do, we can create a follow-up conversation in our Slack channel to discuss that. So I think the main idea here is you need to make sure that your data is partitioned by some immutable date. Like it's usually event occurrence. That's what was in the Igor's example, right? So we worked with events data and we had a immutable date, like when event happened. And then you need to define your backfilling window, basically in using build range and you need to appropriately set it just, like beyond the date. And then you have the rest of the Lambda will come after that. So in that case, Cube works with sort of the two consistent data sources, right? Like pre-aggregated events from the past and events from the real time after a specific date. And in that case, you should not have any duplications and any crossover between these two data sets. I think that question was a follow-up for sure. So anyway, I think Igor, you can feel free to kick off the conversation about it in our Slack.
Great. I wonder if we're going to get any more questions. We have
and apologize, Sushant. I finally fixed the issue with chat. It was like a weird thing in the setting that was hidden, but my apologies. Hopefully it didn't cause a huge problem. But... Awesome.
Yeah,
so
actually,
yeah, I mean, yeah, go ahead, Igor. Sorry.
Oh yeah, there's another question here. So what about the support for joins between streams and batch stores? Wow, this is a tricky one. I wonder.
Yeah, I can try to take it. So we have a roll-up join. So as long as you have a streaming pre-aggregation and a batch pre-aggregation, you should be able to apply roll-up join between the two pre-aggregation. Generally speaking, you should be able to apply roll-up join between any pre-aggregations, regardless they're streaming or regular. I just want to make sure that roll-up join is still work in progress as a feature. So we plan to finalize that zone. So if you try it, please be cautious. And if you have any questions about this feature, ask us. But generally speaking, that's the direction we are taking. We wanted to support that use case with the roll-up join.
Cool. It's like right on time. Thank you, Igor, our team, and if, last but not least, all the attendees for joining us. And we'll do this again in about 3 weeks, and we'll talk to you more about views. Have a good rest of